Hello. Good morning. And thanks, everybody, for coming. Looks like there's a lot of people excited about VR UI. Woohoo. So before I begin, I would like to ask you guys to just turn down your mobile phones. All right, that's good. So first, I would like to ask hopefully an interesting or intriguing question of, is this UI? And as I go through my talk, I will try to explain this in more detail. But first, just a quick introduction. My name is Riho Kroll. I'm a UI designer at Crytek. I'm from Estonia, and I'm a UI designer and developer. So a lot of the stuff that I'm going to show here today is actually, in big part, built by me as well. And I'm quite excited about VR UI. Just for reference, that's Estonia right over there. People always ask me where it is. So what I've done in the past, I've worked on traditional games, mobile apps, and web platforms. And for the last year and a half, I've worked exclusively on VR. So I've worked on the Back to Dinosaur Island demos, 1 and 2, The Climb, our upcoming game for the Oculus VR platform, and Robinson the Journey coming for the PlayStation VR platform. Just out of curiosity, how many of you are actually already working on VR? Just by raise of hands. That's cool. How many of you are designers? Cool. All right. So what I'm going to cover, I will talk about our experience of building UI in world and menus, and just comparing it to how you would do it traditionally to how you would do it in VR. And then I will go into some of the technical details of actually building three-dimensional UI. And later I will talk about the design and production process of building UI in 3D. So to start off with, I would like to talk about in-world UI, or what's more traditionally known as HUD. So in-world UI is, once you put it into the 3D world, once you have these elements in the world itself, it's a part of the experience and part of the immersion. And it can be the case that UI can break the immersion as well. So it could be kind of like breaking the fourth wall in a sense. So sometimes it could be that less UI is actually better. And what are the odds of a UI guy coming up here and telling you not to do UI, right? So how would you convey the same information without what I would call prosthetic UI? So as a very crude example, and I'm sorry for this, you could have a problem where you need to show how many sips are left in this cup, right? So you could do a really fancy UI element that says 6 sips left in this cup, but how else could you indicate that? So you could also just do this, right? And by the way, if anybody is up for beers later, just come grab me later. And to answer the question of, is this UI, that's an example of a save point or a checkpoint icon, so to speak, from our game, The Climb, which is a first-person climbing game. So once you hit this checkpoint, you clip in to indicate that you're now saved, and once you fall, you will always come back to this point. So with that said, sometimes using these in-world concepts or in-fiction concepts can be also too subtle. So you may need a big red button to indicate at some point some gameplay information. So how would you go about building this prosthetic UI? So first thing is, in VR, you can't just put things in the corners of the screen and have them always available to the player. So you have to manage the player's attention and always know where they're looking, what are they trying to do, and what is their next action going to be, so you can show them something like this as an example of how many bonus points they got for this grip in this case, to always know where the player's attention is. And also, you can use the edges to draw attention. So in this case, we're using it to draw attention to the left hand of the player to say that, hey, this is starting to get really tired. And this works really well. And also, for UI especially, or indicating information to the player, audio is way more important than ever. So before it was more of a nice to have in some cases, but in VR it's really quite crucial. So as I'm going to talk about in the next slides about depth, and I can only show you a 2D image of depth, so I'm going to have to ask you to just, as I'm showing these examples of 3D elements, to just imagine that they're in 3D. So something from traditional games that's quite common is objective markers. So how would you go about doing something like that in VR? So you could, for example, scale it proportionally to how far away it is to always keep it consistently sized, which we call inverse scaling in our case. You could make it face the player, so you can always read it from any angle of where the player is in the world. But there's a few problems with this as well. So although it works quite well, it will appear less 3D, because you always expect elements that are further away to get smaller and smaller, right? And also, another key thing about objective markers is that it's usually, no matter where it's in the world, it's always on top. So you can always see it even if it's occluded by something in the world. And this can create a few problems in VR if you try to do this in VR. So first of all, it's an unrecognized concept. So opaque objects cannot be seen through in the real world. And also, you're asking the player to focus on several depths at the same time. So something that's in the foreground and something that's in the background. And this can create this depth confusion. So as an example, if you try to right now focus on something, focus on your hands and then something on the background will split apart, and it will, in VR, look like it's not stereoscopic, if you wanted to show an objective marker through a wall, for example. So that's not to say it can't work. I think it can work, but there has to be enough depth context for the player to understand at which depth this object is at. So you basically need to guide the player's mind and eyes to focus on this depth. Another thing about UI traditionally is that it's usually unlit. It doesn't receive shadows or lighting information. And this in VR can create some problems, because lighting and shadows are actually a really big part of how you can tell what the shape of an object is or how far away it is. But you don't always want to add lighting and shadows to a UI. So how could you be still within your art style and have things still readable? So here's an example of a depth-based shader effect. So you could do something like this, where things that are nearer are lighter than things that are further away. So as you see on the right, the flat circle could be an ellipsoid, it could be a circle. You can't really tell what kind of shape it is. Also, we're using, for actual 3D model-based UI elements, we're using the Fresnel effect for opacity. So if you just used alpha to have only alpha opacity on this object, it could also create some depth confusion because it's not readable enough. So for anybody who doesn't know, here's the Fresnel effect in work. So things that are you're facing directly are less opaque than parts of the object that are curving away from you. So, menus. And when I talk about menus, I mostly mean everything that comes before the game. So everything to do with metagame aspects, leaderboards, progression, achievements, etc. And menus don't necessarily have to be much different in VR. So you could just go ahead and have your menu projected on a plane in front of the player and do some kind of a raycast inside to see which buttons they hit, right? But that's not really taking full advantage of VR, is it? So using the world can add quite a lot to the experience. And as an example of this, here's an early prototype of a score screen we did for the climb. So as you're gaining more points in the game, this mountain grows larger and larger. So we could have done something like a progress bar here, but we instead decided to go for something that's incorporating the whole world into the menu and the UI. So some things to keep in mind when it comes to menus. So a global navigation isn't quite as effective as we found. So using this sort of tab bar at the top, for example. And the reason for that is because the player is always focusing on the content. So being able to reference this global navigation is not always possible. So what we do is we actually separate all of our menus completely. So you have to always go in to a section and then come out to select something else. And for this, we believe that transitions are key to always keep the player or have them understand which section they're in. So as an example, here's the starting a level flow in the climb. So as you can see, the elements are always transitioning to the place where we want them to look and building up this menu as they go along. Another thing that's fairly important is showing the controller layout to the player, especially as you're introducing new concepts to the player, like using a D-pad as part of some menu, which we actually use quite a lot in our menus. And the interesting thing to note here is that we actually don't show the label of a button. We don't say it's an A or a B button. We say we only show the location of this button. And this works quite well, especially for players who are not necessarily gamers themselves. Another key thing is that it's important to always have a grounding of some sort for the player. So menus can be fairly abstract in nature. And if you don't have a grounding or some thing in the background to orient the player, it can create this sensation of falling as if the player doesn't know which direction they're in. So it's we always have this kind of grounding in all of our menus. Another interesting thing that we found is that there's actually a fairly big difference between using a pressed and a released event when you're selecting menu items. So using the pressed event, as soon as you press down the button, actually makes the menus feel much snappier and much quicker to use. And as in our case, we don't have hover areas that can conflict, and usually the errors that that the player could make are super easy and quick to correct. So we actually use the pressed event in all of our menus. So some cool things about VR menus. So first of all, you get the full attention of the player. So you can be sure that they're not going to be distracted by some Facebook event or some other thing while you're trying to explain something really important to them. And another thing is that, again, going back to the transitions, you can always more or less tell where their attention is. So you can always bring in new elements of the menu to explain more stuff to them. And also, menus can be whole environments of their own, or almost even games in their own right. So here's an example of a gear selection menu from the climb. And people actually stay on the screen and play around with these cards just because it's fun. So in conclusion, good UI could be no UI, or using existing concepts from the game world or the real world. And gameplay information is much more difficult to deliver because you don't have those screen edges that you can always rely on. And menus can be really awesome. So on to the technical bits. And I believe as a designer for VR menus or VR UI, you definitely need to know at least some of this knowledge. And that's the reason why I brought this up. And also I'm going to share some of the solutions that we came up with as part of building the climb menu and our demos. So first thing is alpha sorting. And just for my reference, how many of you here know what alpha blending is? Wow, that's actually quite a lot. That's cool. So UI is usually alpha blended or made out of transparent elements for either transition effects like as fade in and fade out, or just you need transparent elements in your UI, right? So the current approach to doing transparent elements in 3D is to sort these elements from back to forth so they can be blended in the end using what's called as the painter's algorithm. So there's a problem with this approach. So let's say we have this blue and the red plane, right? So if you were sorting these elements from the player's view to see, based on, let's say, the bounding box, you could use any reference for the object, right? If you're doing it from the bounding box, you can see that the blue plane is actually closer to the player's eye than the red plane, right? So if you were sorting this from back to front, then you would actually end up with something like this, where the object that you intended to be on top is actually behind. So how could you work around this problem? So first of all, there's order-independent transparency, which we don't use because we found it to be a bit too costly to do accurately, which is important for UI elements especially. So what we instead do is we set offsets during the authoring pass. So we say, for example, that this red plane has an offset in this direction plus 5 meters, for example, just for the sorting pass. And that generally works fairly well. So, text rendering, one of the bigger subjects for VR UI. So, I would like to present 3 different approaches to doing text rendering, which all can be used simultaneously as well. So first of all, there's rendering to a texture and mapping those textures onto a model, right? So we use scaleform to do this. We render our UI elements into a render target and then map those textures onto a model. And for this approach, MIP mapping is quite important. And we use the box filtering on the hardware to do this once we have the texture ready. You could do some custom fancy filtering on top of that as well, but we found that box filtering is quite good enough. And the problem, of course, with this approach is that it's starting to break down at very small sizes. And also, sometimes you just really need a really high resolution texture to pull something off. So another approach to this is signed distance fields, which I believe was first introduced by Valve. So the way this works is that you can give it a really low resolution texture, and on the pixel level, this will then draw very sharp lines around this text. And this approach works actually fairly well, but there are also a few problems with this. So first of all, it's an approximation. So text will appear slightly more rounded around the edges, which can be corrected by using another channel in the texture to add more sharpness. But it adds more step to the authoring process. So for us, we decided to not go for this approach. Another approach, of course, is to actually render 3D glyphs, right? So you could render actual text models into the scene. And right now, we believe that's not a viable solution because of the anti-aliasing, and especially at very small sizes. But it could be the best approach in the long run because this gives essentially true resolution independence. And also, if you do have a really good anti-aliasing solution, then I believe this is the best approach. So in conclusion, we find that rendering to a texture works well most of the time. And just out of these approaches, you could mix and match whatever works best for you. So another key thing about VR UI especially is hover detection. So using, or how do we detect the player's gaze where they're looking at in the world? And usually this is done using a raycast. And we actually use a slightly different approach to this. So we use what we call angle comparison. So we compare the camera's rotation to points in the world, which looks something like this. So the closest element will become the selected element. And this gives us a few advantages. So first of all, we can move these planes quite drastically, so giving player more feedback as they're navigating the menu. And also, we can be much more generous with the hover areas. So they don't have to hit a very exact piece of triangle, right? So, and this is also really good if you don't have a very clearly defined hover area. So if you have just a block of text that doesn't necessarily have something to hit per se. Another thing that's quite useful with this approach is that you can use the proximity of it, so how close you are to this point in the world, to do effects such as making elements smaller or bigger depending on how far away you're looking at them. And it's also much cheaper than a raycast. So there are a few drawbacks to this approach as well. So first of all, of course, it's not precise. So it's, again, an approximation. And it gets tricky when you have a crosshair also in your menus. So it can actually conflict with some of the elements you're looking at because it's a circular kind of hover zone. And this can be worked around, of course, with clever placement of these points in the world. But that's just something to keep in mind. And also, there's no, there isn't an idea of occlusion in this case. So with arraycast, you can have objects occlude the element, but in this case, that's not available. And also, you can end up with quite a lot of tag points in the world. So, anti-aliasing. So anti-aliasing, we believe, is actually quite important for menus. So if you have a lot of aliasing in your menus, which can usually be quite abstract and very minimalistic, right? You can have this pixel swimming effect going on in the background when you are trying to actually explain something to the user, or if there's something really that they're focusing on. And also, with deferred shading, rendering being the standard now in the industry, we have mostly post-process anti-aliasing solutions to rely on. So FXAA, SMAA. And these aren't really great for UI because they work on the whole scene. So even the textures that you've really carefully tried to be very legible are now also being essentially blurred by this anti-aliasing. But it's still fairly important. So in conclusion, alpha sorting can be quite an unpleasant thing to approach as a designer. And I presented a few text rendering solutions that, as you go along, you should find the way that works best for you. And I've also shown a different approach to detecting hover than arraycast. And anti-aliasing can be quite problematic, but it is necessary for menus. So now I'd like to talk a little bit about the design workflow of how I actually start off building these elements. So I spend a lot of time in the pre-production phase. So I do a lot of sketching, and also I try to pre-animate elements using my hands just to get a feel for how an element is going to look and behave in the world. And this can be a really cheap way of just quickly prototyping, at least for me. And I usually, after this, straight go into a 3D app to try to mock this element up and see how it's going to work in the world. And then once the design process itself is done from start to finish, the production workflow starts. And the way this works usually is that I start off with a static UV layout or a texture that I'm going to use in the world. So, you get some cool things like having to UV map your UI elements and worry about, localization and dynamic content and trying to fit all of that into a texture. So after this, I put this in 3D Max in my case and start modeling and animating these UI elements. And then after that, I export that to the engine and chain them up in our animation database solution called Cryomannequin. So this is more of a traditional game development process for which, so our UI elements are quite akin to how characters are set up in a 3D world or a game. And the good thing about this is that it gives us the ability to use animation blending. So especially with UI transitions, we can use the blending features of the animation engine to just quickly stop an animation and go back to a different state and manage different states of an animation and using animation layers when there's multiple elements animating independent of each other. And this can be really useful for UI, especially. So once we have them exported, we place them in the engine and hook them up into our visual scripting language called Flowgraph. And just for reference, that's the menu flow graph from the climb. It's only slightly small. And then try it, see how it works, and repeat the whole process. So, some final thoughts before I leave. So I believe that VRUI has brought possibly the biggest change to UI design ever, and especially for games. And I think this brings in quite a lot of new, interesting challenges that people haven't faced before. So as you guys are working through solving these problems, it could be very likely the case that you are the first person to encounter a certain problem and solve it as well. So we are, right now, basically writing the book about VRUI. And I think that's very exciting. So I think right now is the best time to be a UI designer or a UI developer, and especially if you're working in VR. So that was my talk. Thank you. And if you have any questions, please come up to the microphone and ask them. No questions? Anybody?
Yes, I actually have one.
Yep.
So right now I'm working on a project where I have some UI elements that are always facing the player in the environment. And because of the sensitivity of the HMDs, small head movements like this, you'll see the kind of elements shift a little bit. Are you guys doing any kind of smoothing or anything like that to take care of those cases?
So you're talking about when field of view is starting to affect the element, or what?
Correct. If it's always facing the player, as they kind of move around, sometimes you'll get a little shifting going on.
Yeah, so we have encountered this problem. To be honest with you, we don't have really a solution for it. Yeah, that's all I can give you on that. Sorry, it's going to be pretty hard to solve something like that. I mean, that's fairly inherent to how your cameras work, right?
Right. Yeah, because I found if you're doing smoothing, there's how much latency do you have in the movement to match the player's head before it gets bad. So all right, thank you.
Yeah, no problem.
I was wondering if you were working also on information redundancy, for example, having an information as a physical element, and also in the UI, because we found that it's hard to convey things on different planes, like information that would be far away in the world and information that would be close to the player. I was wondering where your thoughts on this issue.
So you're talking about when you have different depths for information, right?
Yeah, and also reinforcing some information through other ways, like as you said, prosthetic UI and information.
So what I was talking about in the beginning is that, for example, in that beginning example, when you had the edges glowing, right? So we actually use a light in the world attached to the player's hands that's going to glow and spread outwards, so you always see it from the edges. And that's also what I was saying about audio, is that this is the reason why it's more important, because then you're again reinforcing some elements, such as directional audio telling you, hey, look over here, right? When it comes to depth and like having different depths of information, we actually have in our menus some general rules about this. So first, we tried to put everything that's informational, so everything that's just for you to read, into the background, so really far away. So we use the depth as a way to tell the player that, here are the things in front of you that are interactable, and everything that's more about information is in the background and really far away.
Thank you.
Thanks.
Great talk, thanks. Just kind of getting a little bit deeper into the depth issue with things like overlaid UI. Just curious what you guys think when you can have like save menus or HUD type UI that can interfere or interact with scene geometry in weird ways. So you have to place that UI at a certain depth, and if something near field comes in the scene from the world geometry, that can kind of interfere with that UI. And
so you're talking about when it gets occluded by other elements.
When it gets occluded, or you're like, let's say on the climbing example, you're like facing the climbing wall, and the UI might be like punched into the rock, for example. Like, how do you solve those things?
We actually use a shader effect for this, where depending on how far the element is occluded, we add some kind of a gradient, so it fades out into the distance. So there is still some usually there's still some reference to how far the object is, right? And it's in those kind of cases, it's going to be very close to the player. So you still have quite a lot of the depth information from just the two eyes being separated, right?
Okay, thanks.
Thanks.
Hi, thank you again for the talk.
Thanks.
You mentioned briefly that it might be a good idea to rely on audio cues instead of visual cues for UI and VR. I wondered if you could give an example of something that actually turned out to be solved really well by using audio instead of something visual, and if it came across as weird trying to implement something, like a good case or a bad case, whatever you have.
So when I'm talking about audio or these kind of different cues, is that they should all work together with visual cues. I mean, audio cues, what I mean by that is that they're more powerful in VR, not that they could be used completely independently, right? But with that said, we do use, in some instances, only audio. So as I was showing the example with the carabiner, when you're clipping into the rock, it can be the case that sometimes you're not seeing it, right? So it's somewhere behind you or above you. So in that case, we use a very strong click sound, and that usually brings the player's attention to it.
Okay, great. Was there a time when you tried to implement something with audio and you're like, wow, this feels unnatural, or did it just work?
Not that I can think of now, sorry.
Right. Thank you.
Thanks.
Hi.
Hello.
How do you handle switching from, like, I guess, in-game to a pause menu real quick without disorienting the player?
So actually we use, whenever we're transitioning from place to place, so that could be going into a menu or going out of a menu, we use a screen fader. So we fade the screen to, in our case, white, and then when you come back to a different place, we fade it out again.
And they don't get confused, like climbing, and all of a sudden they're in a weird...
Usually not. We try to be very careful about not doing it too often, right? So only when the player has explicitly prompted it, right? So they press the back button to get into the menu, for example.
Cool.
Thank you.
Hi.
Hello.
Have you ever thought about gesture-controlled interfaces? So basically when you use hand skeleton tracking or fingertip tracking, I think it's really hard to show the user at which distance the UI elements are, and I was wondering if there are better concepts than tapping a button in 3D.
So in our case, which is the reason why I didn't talk about motion controls, is that even though we do use motion controls in the climb, for example, we actually specifically stick to the more generic controller layout. So when people are transitioning from the gamepad experience into the motion control experience, that they still have a fairly similar experience. So we don't do anything specific for motion control. So using, like you said, like using your hands to tap a button or something like this. So, yeah.
Thank you.
Thanks.
Hello. How do you think about using a kind of traditional-looking 2D menu, like what you showed, versus using a kind of abstract but 3D environment kind of menu, like maybe Fantastic Contraptions, a good example?
I haven't seen Fantastic Contraptions, so it's hard for me to say. But I guess you mean more about using like 3D, or let's say, yeah, boxes and cubes and
kind of like putting you in a space, and then there's little widgets in that space that serve as the menu in an abstract way.
In an abstract way. Interesting. Well, to be honest, we felt that for the climb menu, especially, and the reason why we're using these more 2D-looking effects is that we wanted to have a very focused experience, something that's still very familiar to the players, right? Coming from 2D 2D screen-based games when they first coming into VR. So for that reason, we decided not to have something where you're like moving things around in the environment and this kind of stuff. So we wanted to have something that's still a little bit familiar to the players.
Along those same lines, I was wondering if you have a philosophy that helps you determine whether to create like a very UI-y menu versus something that's embedded in the real world. Like,
so,
let's look at the watch versus bring down a menu.
Right. So actually, the watch is a good example because we do have a watch in the game that you can look at. Yeah. So actually, when it comes to everything to do with in-world UI, the first step is always to try to find something that fits the world, that is part of the fiction or that is part of the real world. And if all else fails, that's when we say, okay, we need to find something that where we use this prosthetic UI to convey something.
But what's the criteria for failing in that case? It's just it's too awkward, it's not fast enough, it's unclear?
It's unclear. Basically, that's the criteria. So as a good example of this, when we were first prototyping with the climb, you could chalk your hands in order to give you more grip, right? And we indicated this by having just the chalk fill up on your hands so you could see the texture on your hands, right? And we tried this and we increased the effect and tried to do everything we could to make it apparent in the world, but it's still not subtle enough. And in this case, you also need to prompt the player to say, well, you need to press this button to re-chalk your hands. So this is the kind of criteria. And also when this interaction of this gameplay is just, it would be too difficult to convey in like having just 2 or 3 concepts in the real world. So re-chalking and stamina and strength of the player's hands all combined into one, that would be a criteria for something that we could do with prosthetic UI.
I see. Thanks.
Thank you.
Well, a few of the issues you mentioned definitely feel unique to VR. I feel like most of the things you touched on are actually would be very applicable for regular 3D games. What are your thoughts on that?
So it's because of VR that we're actually inside of this world itself, right? So I think going back to the other question about some things being just too subtle, when you have a 2D screen with a 2D game, right, it can be even more subtle, I think. And it's because of VR, because you have this, you are part of this world where I think that using these in-world concepts can really work.
Okay, I mean, so getting back to my question, I mean, I've seen many games, like, for example, one of the issues you mentioned is using the real-world cues. I think Dead Space was a good example where actual world was used to actually indicate all the UI elements. So I feel while the VR is definitely enforcing more immersion, I don't feel it's really unique to VR as much.
That can be true, but I still do believe that because of VR, because you are part of this world, these cues are easier to convey to the player.
Thanks.
Thank you. Any more questions? Well, I guess not. So thanks a lot for coming. I hope you have a very good day.